Hello. Good morning. Oh man, I stayed up way too late last night. I don't know why, I just couldn't fall asleep. Wait for a couple more people. Dum dee dum. It's a question about how much more Attack on Titan did I watch. I finished the first three seasons, and um, for me, I felt like the where the series went. I don't know that I really liked it, because I feel like the first three seasons are kind of about one thing, and then the fourth season it just kind of like switches it to something else, and it's like, well, I got invested in the show being a certain way, and then it just kind of like was like, oh, it's not actually that way, it's this way. Wah! And then the fourth season is completely different. So um, I don't know. All right, well, we better get started. um, and autofocus. Um, okay, I am gonna watch season four. I just like it just took my mind a bit to process like the change between season three and season four. It just seems like a completely different show almost. um, okay, so the first thing I want to talk about, and I think I forgot to talk about this in my pre-recorded lesson, and that is the idea of um, masks, a mask. Okay, and this comes from um, a mask comes from uh, bitwise operators. Okay, so basically, what we're going to do is, if we wanted to take a sequence of bits and only um, and basically select a certain number of them. Okay. Um, Only select certain bits. So what if I had the bits um, maybe 0, 1, 1, 0, 1, 1, 1, 0. Okay. And I'm interested in only these first four bits. Okay. I don't care about what the other ones are. I only care about what those first four bits are. Okay. Then what I could do is I could bitwise and with 0, 0, 0, 0, 1, 1, 1, 1. Okay. So this would be, in this case, this would be the mask. Okay. Because if you take any bit and you AND it with 0, it's going to give 0. Okay. So basically, these 4 bits that get ANDed with 0 are just going to get killed. So we'll get 0, 0, 0, 0. Okay. And then if I look at the last 4 bits, those are ANDed with 1. And if you take something and you AND it with 1, it's basically like the identity function, okay? 0 ANDed with 1 is 0. 1 ANDed with 1 is 1. Okay? So I have 0 ANDed with 1, that's going to be 0. I have 1 ANDed with 1, that's 1. I have 1 ANDed with 1, that's 1. I have 1 ANDed with 1, that's 1. Okay? So this would be the result. And so you can see that these 4 bits match these 4 bits. Okay? And then everything else is set to 0. So I'm selecting certain bits using the mask and bitwise AND. Okay? So type it into the chat if you could tell me what would be the mask if I wanted to, what would be the mask if I wanted the middle 4 bits. Type it into the chat if you know the answer. Okay. And the other thing I wanted to point out is that 1111 in hexadecimal is F. Okay. So I could actually think about this mask as 0x. Remember, 0x means hexadecimal. This is 0, and this is F. So in this case, my mask is 0x, 0, F. Okay. Excellent. Yeah. So if I only wanted the middle 4 bits, then my mask would be 0, 0, 1, 1, 1, 1, 0, 0. Something like that. Very good. So I think the bitwise assignment for the SL class has you use a mask at one point. So I realized that I forgot to talk about masks. So that is a mask. Okay. So the next thing that I wanted to talk about is what is called a hash function. Okay. So a hash function is also known as a one-way function. And basically what a hash function does is the output of the function so you know what a function does is it takes in an input and it gives you an output. The output of the function is related to the input. In a way that is so complicated that it seems random. Okay, it's not random. If two people put in the same input into the hash function, the output is going to be identical, on two different computers, but it's so complicated. So basically, if we think about the function f of x equals x squared, this is not a good one-way function, because if I said which value of x, okay, has f of x equals 16, okay, I think it's really obvious that the answer would be x equals 4, right? Because 4 squared is 16. So that is really easy. So we can find f of x easily, but then if I want to ask the question which value of x results in a certain value, I can do that fairly easily just by taking the square root. Okay? But a one-way function is the opposite. It's easy to calculate the function. So you could calculate f of x, but if I asked you which x value results in the function having that value, it's basically impossible to do, because the output is related to the input in such a complicated way. All right? So if you had a hash function, so like what if I said, the hash of x is equal to, I don't know, and I'm going to write the number in hexadecimal. So maybe it's AB4310FF. And I wanted to say which value of x will result in a hash that is equal to AB4310FF. The only way to solve that, okay, is to guess and check. So you would have to try hash of 1 and see what that equals. Hash of 2, see what that equals. Hash of 3, see what that equals. Hash of 4, see what that equals. And you just keep going and keep going and keep going until you guess the value of x that results in that hash. So it's extremely labor intensive to guess the value of x that results in a given hash. Okay, so that's what a hash function is. All right, so there's a hash function called SHA 256. All right, so SHA stands for Secure Hash Algorithm. And I believe it was developed by the government. And then 256 means the output is 256 bits. So it's like a really big number, okay? 256 bits. Okay? So basically, the number of possible outputs, what's going on? Number of possible outputs of this function is 2 to the 256. All right, because each each bit could be 0 or 1. So the number of possible outputs would be 2 to the 256, which is basically approximately equal to the number of atoms in the visible universe. Okay. So there's a lot of the number of possible outputs of this function is finite, but it's a huge, 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 huge number. Okay. So for you to guess and check, to guess and check would be like trying to guess a single atom in the entire known universe. You know, it's like really difficult to do. Okay, basically impossible to guess. 256 bits is also equal to 64 hex digits, because each hex digit is 4 bits. So, all right. So let me show you what I mean by that. Okay, so I've got a web page here. All right. And you can type in a message and it will give you the SHA-256 hash of that message. So what if my message is hello? All right, with a capital H. Here's the hash. All right. You know, it starts with 185F8DB. So this is 64 hexadecimal digits. So see how it goes from 0 through 9 and then A through F. All right. Now, what if I change this to a lowercase? The hash completely changed. It's like you could not guess the relationship between lowercase hello and uppercase hello. They result in completely different hashes. Okay. See? Look at it. There's like basically no digits are the same between these two hashes. So you can see that it's basically impossible to guess what the hash is going to be. If two messages are very close to each other, they have completely different hashes. Hello, Ryan. Okay. Has that. What if I forgot to capitalize the R? Completely different hash. Okay. So that's the way hash functions work. You take in a string. You take in a string, and the output is basically a random huge number. All right. So how are hash functions used? One of the ways you can use them is to make a digital signature. And this is what your assignment is about today. Okay. So what if you wrote a document? So maybe your document is, "Hi, Mom." Okay. And you wanted to prove that you wrote that document. Now, this is a really simple document. You could imagine, okay, you could imagine, you wrote an extremely important scientific paper and you want to prove that it was you that wrote it and not someone else who's claiming to have written it. Okay. So one of the things you could do, all right, is you could provide what's called a digital signature. Okay. And so basically what you would do is you would come up with a passphrase. Okay. So maybe my passphrase is going to be equal to I don't know. I'm trying to think. Cat. Okay. That's not a very good passphrase, but and then what I'm going to do is I'm going to concatenate that onto my message, okay? Or onto whatever I wrote that I want to prove I actually wrote this, okay? So now, so I'm going to let x equal to cat hi mom. All right. And then I'm going to compute SHA 256 of x. All right. So let's do that. So I want to compute SHA 256 of cat hi mom. Okay. And it has this value. It starts with CA. All right. CA78. All right. So now what I would do is I would publish. All right. I would publish hi mom. So this hash value right here is the signature. All right. So I would publish hi mom, and then I would also publish the digital signature. Okay. CA78 ... Okay, it's a really long number. All right. So now what happens if someone else wants to claim that they wrote hi mom? I would say, all right, give me the passphrase. All right. So, and then that person is going to say, oh, the passphrase is dog. Okay. So then I'll be like, all right, I'm going to check. Is dog really the passphrase? And then what I would do is I would go to here and I would try out dog hi mom. And I would see what is the hash. And I can see that the hash doesn't even start out with CA78. So I can say, you don't know the passphrase, so therefore you must not have written this document. Okay? So only the person who has the passphrase can produce the correct digital signature. All right? And that has to do with the fact that the SHA-256 hash function is so complicated that it's impossible to guess what the passphrase would be. The only way you could do it would be to just randomly try a bunch of passphrases until you got the correct signature, which would be extremely labor intensive, okay? Because the number of possible signatures is equal to the number of atoms in the visible universe. All right? So this is how a digital signature works, and I think it's kind of cool. So let me show you how this works in Java code. Okay. Where's the right thing? All right. So I wrote some Java code for okay. So let me make this a little bit bigger. So if you want to so Java has the various there are multiple hash functions. SHA-256 is considered a good one. There's also SHA-512, which is considered even better. But whatever hash function you want to use, you need to import java.security.messageDigest. Okay. So this has the hash function. Okay. So then I wrote a public class called hash functions, and there's a couple of methods here. So the first method is this one, and it's called get hash. And so it takes in an input, and so the input is the message that will be hashed. Okay. And then the output is the hash value. All right. So I have a string hash value, and notice how at the end of the function I return the hash value. Okay. You have to put your, when you do the hash function, you have to put it in a try-catch block. So I have a try-catch block. So the first thing I am going to do is I'm going to convert the input to a byte array. All right, so the string class has a method that will convert a string into an array of bytes. Okay, so that's what I've done. And then what I do here is I create a message digest object. And so you can see I have message digest, and I called it message digest, and it's equal to message digest.get instance. And then, so this is more or less the constructor of the message digest object. And then in the parentheses, I put the algorithm that I want to use. Okay, so like I said, this could be SHA 256, could be SHA 512, could be SHA 128, etc. Okay. Then I'm going to plug in the input byte array. All right. Into the message digest object. Okay. And this is why we had to convert the input string into a byte array. Because of the way that the message digest object operates, it takes in a byte array. So we needed to convert the string to a byte array. All right. All right. And then what you do is digest, message digest.digest, and digest is the function that runs the hash function. Okay. And then the output is another byte array. Okay. And then I have a function right here. Then the hash value is byte array to hex, because typically a hash value is going to be given in hexadecimal. Okay. So byte array to hex. So convert the output byte array to hexadecimal. All right. And so that's, and then I output the value. Output value. Okay. So, and then I wrote a couple of functions. So byte to hex will take in a single byte and turn it into a hexadecimal. Okay. And then I wrote the function byte array to hex, which converts a byte array into a hexadecimal string. So basically, there wasn't a way to convert a byte array into a hexadecimal string, so I had to write my own methods to do that. And that's not really that important. So now I have the main function right here, and basically what I have right now is I'm going to print out the hash value of a string. All right. So what if I wanted to get the hash value of cat? Okay. So I will compile it. It compiles, and then I'm going to run it. And I can see that the hash value is 77F77B51B435, blah, 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 okay? So let's go back to the website here. And what if I do the hash of cat? Okay. Okay. Why isn't it the same? It's like almost the same. 77F 77B51. That's weird. I wouldn't worry too much about that. I don't know why it's not matching this website. Like the other night when I tried this out, it was matching the website. So I think it might have to do with. So what's going to happen is you might get a different value from this website. But the thing is that basically the reason it's different is because when I did byte and I did get bytes, different computers will convert strings to a byte array in different ways, and so that's why these hash values are slightly different. So, you might get a different value from the website. I know that I've tried it before and I got mostly the same value, so I don't know what's going on there. All right, so basically what you're going to do, if you're an HL, is you're going to write a program that allows you to type in a document. So it's going to prompt the user for a document, and then it's going to prompt the user for a passphrase, and then it's going to produce the digital signature. Okay, so that's basically the assignment. There are a couple of details, and you can read that in the assignment description. All right, so that's my lesson for today, and I will see you in the Zoom room.